I'm George. I work at Genuity Science. I've been here for about 3.5 years now, working on this journey. So let's talk about the automation journey. A lab was a building site. We had nothing. We had a temporary lab at UCD, and we had a NovaSeq and a Hamilton, and that was it. And basically, at that time point, we're getting in a few samples a week. But the proposal was that, we want to get to a stage where we can sequence in the first iteration about 20,000 samples a year, whole genome, end to end. And then as we progress, to then scale that even further. So what my first job was to do was actually develop how we're going to do it, put it on paper and plan it out, and then layer this process over the lab itself. So by combining these things, it kind of gave us an idea of how we need to build the lab and what equipment we would need to enable this workflow to function, especially at high capacity. This is now where we're at currently, and so we're focusing on rare disease, but this process works for everything. So it was also to make this process adaptable to running normal samples that are coming through the lab, but also to be able to work with a rare disease in tandem and allow these to go through. One other thing that was very critical is, because often these patients are waiting a long time to get a diagnosis, we wanted to decrease the turnaround time when it came to rare disease patients. And this is accomplished through the workflow. So you'll see here in this kind of chart, all the steps in blue are the steps where it's entirely automated on Hamilton systems. Like I said, we started with 1, but we now have 6 and a 7th on the way as we've expanded the fleet, allowing us to increase with each iteration more and more throughput within the lab, but also diverging processes as part of our plan. So not only looking at whole genome, but also RNA-seq, WES, and using this to layer in. We then have a 4-step QC mechanism. Because the blood, you can get a high volume of DNA, and what's really important for downstream workflows is that we have a sample that is not only good, but is directed specifically to what we need for each of the processes. So you can see here this 4-step process where we do an initial QC, we then normalize the plate and re-QC it to just make sure to give us this fine tuning that we require to get the samples at the concentration we need. We remove any QC fails so that only the plates at the last step, step 10, are the ones that are all good and can proceed to genotyping and sequencing. So we do both, and the reason we do that is for not only just as a good check to see that the DNA is good, because genotyping is a lot cheaper, but it also allows us to do a concordance check with the sequencing to make sure that the sample definitely is the sample that was submitted. So this process allows us to work with up to 96 samples at a time, and is a very quick procedure. You can do this about 3 or 4 times a day, so it really gives us a high volume of throughput within that laboratory. The next step, and so in pre-PCR as we move on, is the library prep. So we currently have 2 Hamiltons in this laboratory, and these are now being developed to run multiple different library workflows. So you'll see here, TrueSeq PCR-free, nano, stranded RNA, and SureSelect whole exome. Now, originally we only started with whole genome, but we've expanded this over time and allowed us to upscale our throughput. Another sort of challenge in this is not only taking these workflows and working with a consistent deck across the robots, because this is really important if you want to scale up you just add another robot and don't have to modify any methods, it makes it better. But also to incorporate the 96 channel head on these instruments. So we worked with Hamilton with the NGS star and modified it so that we could allow throughput using the core head and not just the single channels to try and increase our rates. And you'll see here a sort of rough estimation of how long each of these processes take. The next step is actually the quantification of these libraries. So we have two different setups in our final lab, our sequencing lab. One at the top is the Hamilton system with an ODTC. So this is optimized for our RNA workflows and our exome workflows, as well as nano, so that we can do all the PCR as part of the actual method. So it's a walk-away method, and all these steps can continue. The lower one highlights our QC instrument. This performs two functions. One, it does all the prepared library QC. We use a light cycler to confirm this, but it also allows us to then do the pooling on the instrument. So what we've got then, when we go into the final pooling stages, we've built a deck here that can accept up to 20 different library plates. So almost 2,000 libraries in a single pooling, and up to 48 library tubes, which is enough to keep 12 NovaSeqs running continuously. And this takes about 3 to 4 hours to complete when we're at full capacity.